Hello, I'm Silvia Labarriaga and I work at the Academic Medical Center of the University of Amsterdam. In the last 5 years we've been working with using grid computing for empowering users in the AMC to do their analysis on the grid. And we used the idea of building web portals that they can do it in an easier way. And these are called Science Gateways, so this is what I'm going to talk to you today. It's about a brief introduction to Science Gateways in general. Okay, so the motivation to include a brief lecture on Science Gateways in this course was to show that there are other ways of doing using grid computing than you are learning now, and that's called Science Gateway. So what you're probably learning now is that you have to take a lot of care of a lot of details to be able to use a research infrastructure. So you have to know where's your data, you have to organize your jobs, you have to organize how do you exchange data with people, and you have to coordinate things that, for example, if it takes 1 year to achieve a certain result, that has to be, organized, put in databases, etc. So the Science Gateways is an effort to try to improve the way that we do that. Still, we're using the research infrastructures, e-infrastructure, but the idea is to provide better interfaces for doing that. So, in this lecture, I'm going to present very, very briefly basic concepts and types and a bit of terminology of Science Gateways. And I'm going to present a little, some of the Science Gateways and initiatives in particular that you can go further and look for your own sake what is out there that could help you in particular. So first of all, what's a Science Gateway? Well, it's an interface to an infrastructure. It's called e-infrastructure when it's enabling e-science. Normally, and that's very important, it's a tool or a set of tools that have been developed for a certain community. So the fact that you have a certain a common goal or common way of doing things is very important for the success of a Science Gateway. And it can be methods, for example, how you submit jobs. It can be also data that people share with each other. Normally, a Science Gateway is all these tools are integrated on a portal. So a portal is a website with services in the back. Normally, people also try to make the user interface appealing, but also easy to use and streamlined to the type of activities that are important in that particular scientific field. And it is then very much customized for a specific community, and that's normally means that the Science Gateways are built by the communities themselves. For example, heliophysics is a field, they have a project, they decide to build a gateway, and then they deploy that and make available for heliophysics, which is a completely different story than is going to be for the astrophysics or for the neuroscientists. In the past, and also in the present, there are different ways to refer to the Science Gateways. For example, some just say portal, or they say virtual research environment. That's the terminology being used currently by EGI to give a name to this set of tools. Collaboratory is also another name, or virtual laboratory of problem-solving environment. So all this means ways of making usage of grid infrastructure, which means software and hardware, easier. There are different types of Science Gateways. Depending on the functionality that they offer, they can be seen as generic Science Gateways or dedicated to some scientific area. So generic means a web interface or a portal that allows people to submit jobs, for example. That's a generic one because you can do any type of science in it. For example, access to files, to do grid authentication, to check the status of your files, of your jobs. There are many different ways of different examples. We are going to, in this course again, we're going to use one of these. It's called WSP Grade. But there are other gateways with different technology that have the same aim, which is facilitate the submission of jobs on the grid. And the other type, which is called then dedicated or customized, is really built for a certain community on a certain scientific field. And then examples are your science gateway, protein docking, etc., like I mentioned before. And what is important, I think it's a major difference between these two, is that this one has, the customized normally has some access or facilitated access to the data resources that are important in that scientific field. Whereas this one is really the files as just filed on the grid and can be anything. Considering the way that the science gateways are built, anything that is important that submit jobs can be called a science gateway. But there are different types of technologies that you can use. You can use custom technology. That means you just, write your scripts and you write your PHP scripts and you put that behind some website and then you have a science gateway. That's possible and that's used, and there's nothing wrong with it. What we see a trend nowadays, because these science gateways can be quite difficult to build, is to use science gateway frameworks. So there are different frameworks that have been thought, and these frameworks actually have basic functions that can be useful to build such a gateway. And then examples are, for example, doing this WSP grade that we are going to use. We are going to use the generic part, but it can also be customized and seen as a gateway, as a framework. And there's also a Catania science gateway. There is also Hub Zero, which is a framework used in the US. So there are different tools that can be used. So what is typically the function that a science gateway offers? So as I mentioned, the data part seems to be for some areas not completely the case for all areas, but in many areas that we see data-intensive science, the data is the center of attention, and you need to do computing because you have a lot of data. So data management is a very important part of the science gateways. For example, where do you store? How do you transport the data from one place to the other? How do you manage the life cycle? Life cycle meaning when do you delete the files from the grid, for example? When you archive things? When do you need them online? When do you need them in a backup tape that can take days to retrieve? So this is all management. And also when you archive and you can get it back. Metadata and the provenance of the data is also very important. It's outside of the scope of this grid computing story, submitting jobs, etc. But it's very important to see in the scope of the scientific problem that people are trying to solve. So you need to have description of your data and the data that you put in the jobs, but also the data that you generate out of the jobs. It's very important to keep track of what they are, not just files, but also to keep track of what happened to them. That's called the provenance or the origin of the data. So these are things that are normally taken care of by such a thing like a science gateway. And of course, the processing, which is why we are here today, is the grid processing is what is in the back of a science gateway in the scope of what we are talking today. And the community, meaning people that can share stuff with each other. So this is also part of a science gateway. So if you see a science gateway from a very, very naive perspective, you have people, that's the community, you have these resources, which can be scientific applications, can be data and metadata, and it can be computing resources of any kind. And what you have is a layer called the science gateway in between that makes easier for these people to use this stuff from a web interface. So comparing a little bit, you have generic gateways and you have customized gateways, and they have different properties. First of all, the generic gateways are meant for people that are normally advanced users, like you. You are able to write grid jobs, therefore you are already an advanced user, but not concerning the gateway story. And you have customized gateways for people that do not know how to write jobs. So if they want to run the job, somebody else has to write the program that runs the job and then has to put in some kind of simple interface. So another difference that's very important is that the customized gateways only run predefined applications. So if you are happy with whatever somebody else put on the gateway for you, then you can use a customized one. If you like to program, then you need a generic one, and that's probably the case of people following this course. The user interface for the generic gateway is normally very, very detailed and has lots of options, and you're going to see that in the exercises. It has a lot of details because it can do lots of stuff, and you have to configure all that. In a customized gateway, you normally have to press one button and then you go. The data management part is normally poor in generic gateways, just files, and very rich and customized. And normally in the generic gateways you don't have any collaboration facilities because each person goes there as an individual. It doesn't have to be like that, but it normally is. And in the customized, you normally have the community sense. People go there to do something together, and therefore there are functions that support exactly that. So to show you that there's a lot of activity in the world around science gateways, I would just like to give you some pointers to further information. So there is one registry of science gateways that is maintained by the European Grid Infrastructure. You can see the link here. You can go there and see what's the definition, who is working with what. There's also a list with a bit of documentation and pointers for available gateways. It could be that there's already a gateway that you could use for your own research instead of programming your own jobs. And there is also a list of available technologies to build gateways. As I said, these frameworks that are popping up here and there are also linked there. And I would like to mention to you two projects. I do not want to be unfair to the many others, but these are ones that I can mention. They are big, they involve a very large number of communities. And one is in the United States, it's called Exceed. And this project aims at building science gateways for various applications that use the American cyber infrastructure. And the Cybers project is a project that is exploiting this WSP grade platform and customization for different applications, and that's also involving now various activities in Europe and also a bit beyond Europe already. So to wrap up, the message here is that these science gateways can help you or your friends to reach this great computing and other resources offered in science infrastructures. There are many already that do that. You should, before you start to build one or start to shoot your jobs, maybe you should take a look to see if you find one of your interest. And there are many customized gateways that you're going to see in this week. Examples of two gateways that are built for, one of them for astrophysics, visualization of astrophysics data, and the other is for virtual imaging platform for simulation of medical images. And the first one is built with the WSP grade framework, and the second is based on the Motor workflow management system and the Google toolkit as framework. So they are good examples of completely different development strategies that were used to reach the same goal. Finally, the acknowledgements to the various projects that we are using to actually develop the Science Gateway. And with this I conclude this lecture. I hope you understood a little bit about what's the Science Gateway and how it probably is meaningful for your own research. Thank you very much.